Okay, so we're now looking at B. You can try to pause it and solve it on your own. We see if we're going to get the same results. Alright, so the way we did the first one is the same process we need to follow with the second one as well. The same steps we follow. Let's look at case 1 or step 1. We'll be labeling them as cases. Case 1, we're testing for n is equals to 1. So you're required to write them the way I'm writing them. Don't omit this part, because it is very important that you show to say you are now on this particular case or step. So the first case is testing for n is equals to 1. This, as we know, it is a base case. In case you didn't know how to term it, it's a base case. So you are testing for n is equals to 1. What are we doing? Left hand side compared to right hand side. For the left hand side, you only get the term which has n, and this is the last term which is n squared. Remember, in the question we've been told that n is a value from the set of positive integers, which means a natural number. So here 1 is a natural number, so it satisfies our condition. So where there's n, substitute with the 1, so this would be 1 squared and we obtain 1 left hand side. Let's now move to the right hand side. Right hand side, what do we have? We have this n plus 1 in brackets, 2n plus 1, everything divided by 6. So n is multiplying with this part and that part. Like what we did with the left hand side, we are substituting with the 1 wherever there's n. So what do we have? We have 1 where there's n here. Then in brackets you have 1 plus 1. This side you have 2, 1 plus 1, everything over 6. Okay, so what's next? We have 1 multiplied by, what is 1 plus 1? This is 2. Multiplied by, this is 2 times 1, which is 2, then plus 1, that is 3. Everything over 6. 1 times 2 times 3 gives us 6. Then over 6, sorry. 6 over 6 gives us 1. This therefore gives us that. This therefore, we now have that case 1 holds. Okay. Case 1 holds. Since this is true by case 1, we proceed to the next case. Let's use the other part. Case 2. This one is an assumption. We assume that n is equals to k, since the first case holds. So meaning, from our mathematical statement we have, wherever there's n, we'll replace with k, both sides. So this gives us 1 squared plus 2 squared plus 3 squared plus. Here we have n, and n is equals to k, so let us replace with k. Since our n is squared, even our k will also be squared. This is equals to k here where there's n. Then in parentheses we have k plus 1. And the last one is 2k plus 1. Everything divided by 6. So that's what we have for the first case. For the second case. Alright, let's move on to the third case. This is where we get to our issues a bit, but don't worry, we are here for you. So the third case, test for n is equals to k plus 1. Alright, so what do we do? We're going to write this statement. 1 squared plus 2 squared plus 3 squared plus, here where there's n, since it is the one we are substituting with k plus 1, we're going to have it as k plus 1 here squared. So k plus 1 is a substitute for n. This is equals to, coming on to the right hand side, here where there's n, replace with k plus 1. Multiplied by, here where there's n, replace with k plus 1. Then add with 1 here. Multiplied by, this other side you have 2. Let me squeeze this part. Here where there's n, you're going to replace with k plus 1. So this shows that the reason why I've indicated brackets is because it is multiplying with 2. So that's why I've put brackets there. It's everything altogether times 2. Then we add the 1. Then over 6. Okay. What do we have next? Left hand side can be maintained. K plus 1 is the last term. Squared. Then this is equals to k plus 1. Now this will be k. 1 plus 1 is 2. Now here, we can do a bit of some basic mathematics. So you expand the brackets, it will be 2 times k, which gives us 2k, then plus 2 times 1 is 2, then plus 1 outside. So this will give us 2k plus 3. Okay, so we'll write it here. Everything over 6. Now remember what we did with the first case. What we did was, we had to find the term which was just before the last term. And this is just a bit similar to the first problem, just that the sum is having each term squared. So either way, it's the same case. What we have is just 1 squared plus 2 squared plus 3 squared. The difference is 1. So meaning that before k plus 1, when you subtract the 1 from this, k plus 1 minus 1, 1 and 1 will go, you're left with k. Since this is squared, the same way everything is squared, even this will be squared, then we have k plus 1 at the end, squared, this is equal to the right hand side. Over 6. Now recall, from the second case, this part here is the same as this one. Hence, we substitute with what is here. And on the right, for this part, we have that. So we'll make a substitution. So this is k multiplied by k plus 1, 2k plus 3, plus 1, divided by 6. Then we add together with k plus 1 squared. This is equal to the right hand side, which is k plus 1, k plus 2, 2k plus 3. Everything over 6. Now, what do we do next? What we do next is simplifying the left hand side. The end result should give us right hand side. And if that happens, then our statement is true by mathematical induction. Left hand side. So this can be expressed as a single fraction, divided by 1, common denominator is 6. 6 into 6 gives us 1. 1 times the numerator will give us the numerator the way it is. Then plus 1 into 6 will give us 6. And 6 will come and multiply with the numerator. So we get 6k plus 1. Then you square. Now what we have next, if you look at the numerator, this part and that part are the same, hence they are supposed to be factorized. So when we factorize this, we get k plus 1 outside. We have, on the first part, to be left with k multiplying with 2k plus 1. Then plus, this side, since one of the k plus 1 has been factorized, we will now be left with one of these. Okay, then everything over 6. So this is what we have. What do we now do next? The next step is we maintain the k plus 1. So we expand because we want to get rid of the brackets. So the k is to be distributed with everything inside brackets. So it will be k times 2k, which gives us 2k squared, plus k times 1, that is k, then plus this side 6 will be multiplied by k, this is 6k, then plus 6 times 1, that is 6. Everything is being divided by 6. Okay, so what we have next is, this is k plus 1 in brackets, then we have 2k squared plus this k and the 6k will be put together, they are giving us 7k, then plus 6 equals to 6. Now this part we have can be simplified. Being a quadratic expression, in this case we're going to factorize. So what we have is this. Let's look at this pattern. We're going to find the product for just this quadratic. The product is multiplying the coefficient of k squared and the last number here. So this is 2 times 6 giving us 12. The sum is the mean two term, which we have as 7. Then the factors are two numbers such that when you multiply the same two values, they should give us 12. When we add them, they should give us 7. So these two are 4 and 3. 4 times 3 will give us 12. 4 plus 3 will give us 7. Now what do we do next? We maintain this k plus 1. We multiply with, we write out 2k squared. Now, as we know, say 7k can still be written as 4k plus 3k. It will still give us 7k. Then we end with 6. Everything over 6. Now look at this. For this quadratic, it has been magnified a bit, hence we now have 4 terms altogether. So we can put the first two together like this in brackets and the last two like this. So what do we have next? We maintain the k plus 1 this side. Now for the first set of brackets, you notice to say we have two parts and we have common values for these two. What is common is 2k. So what you have is 2 is out and one of the k is also out, so you're left with k. Then plus this side k is out, so what are you left with? The 2 here. Then plus this side, what you have which is common is 3. Then you're left with k plus 2. Everything over 6. Right, this side. So this gives us k plus 1. Now you notice that there's k plus 2 and k plus 2, so we'll write it like this. As we know the way we do it with our quadratic expressions. Then you'll be left with 2k and 3, also with their own bracket. Then everything over 6. Then upon observing, this part and this part are the same. This was the right hand side. This is the left hand side. So it therefore concludes, say, the statement is true by mathematical induction. Alright, so this is the second problem. Please make sure that you follow each step closely. Let's now move on to the next one.